So I think we already stopped from here, scalar product or the dot product. Today we will be moving to the magnitude of a vector. Okay. So when it comes to magnitude of a vector, as we already discussed, so vector has both the magnitude as well as the what we call the magnitude as well as the direction. So that's why it's coming under vector. If it's a scalar, that means they have only magnitude. They have only magnitude, but for the vectors, they have both the magnitude as well as the direction. So now when it comes to magnitude of a vector, as we already know, for example, if I show you with an example, let's assume that I have a u vector called 3 minus 5, 2. Okay, which means the u vector is, so if we wanted to find the magnitude of the vector, then it will denote like this with the modulus mark, but we are using two lines here. It will be how we calculate the magnitude, that is 3 squared plus minus 5 squared plus 2 squared. Okay, so 3 squared plus minus 5 squared plus 2 squared. That's how we calculate the magnitude of the given vector. We just squared all these x, y, z components and add these together, and then we'll find out the square root of this. So 3 squared, there we have 9, plus minus 5 squared, there we have 25, 2 squared, that is 4. Then the square root of this entire one, it would be square root of 38. That's how we find this. Okay, is it clear?
Yes.
Okay, so let's assume, so earlier on this question, all these three components were what? All these three components were the numbers or the units. But here for the second one, they have given the magnitude as 8. They ask us to find the vector. So how are we going to do that kind of a question? So they have given us the magnitude of the vector and they have asked us to find out the vector. So vector, so this given vector is a 4-dimensional vector because we have 4 units, right? Minus 3, a, 2, minus 4. Only value which we need to find out is that is a. So how we gonna do that? So this magnitude 8 should equals to the square root of the addition of all these square, which means square root of minus 3 squared plus a squared plus 2 squared plus minus 4 squared. Then what we do? To remove this square root, we just squared. To remove this square root, we just squared
Yeah.
Yeah, we just squared these ones, that is 9. So, sorry, before that we have to squared this one, squared in the sense, then let me, left hand side, the squared of 8, that is 64. 64 is equals to 9 plus a squared plus 4 plus 60. So we have 64 is equals to 9 plus 4, that is 13. 13 plus 16, that is 29, plus a squared. Then we can have this a squared value as 64 minus 29, that is 35. 35 is equals to a squared. So the value of a would be, we can get two values by square rooting both sides. Then we have plus square root 35 as well as minus square root 35. Is it clear?
Yeah.
Okay, that's how we normally find these kind of questions. Okay. Now we are learning the theorem. So the new theorem, it says, let this u and v be two vectors. So we have two vectors, vector u as well as vector v. So both these vectors are in the r to the power of n space. That means we have to define these vectors with n number of components. And also there's a constant called k. So k is in real numbers. This k is in real numbers. Now what will happen? The first theorem would be the magnitude of this vector u is equals to 0 or else greater than 0. Is it clear?
Yeah.
Okay, the first one is that one. Then the second one is, the magnitude of this vector u, the magnitude of this vector u is equals to the magnitude of this minus vector u as well. So minus vector u means we have the same magnitude, but the direction of this vector has been reversed or opposite. If we consider earlier the vector u like this, now if it's minus u now, then we have to think about the opposite direction. But still, these two magnitudes are equals. Is it clear?
Yes.
Then we have the third theorem. So what does it says? The magnitude of the ku vector. Ku vector means, can you remember we did the scalar multiplication? Then
Yeah.
for this vector, we have multiplied it from this scalar, that is k. The magnitude of this entire ku vector is equals to k times magnitude of this given vector u. First, we can find out the magnitude of the vector and then we can multiply it by the k constant. That's what here we have as the third component.
Okay, is constant.
K constant. Here we have the k constant. K is the real, any kind of real number. Okay. Now what will happen? As the fourth one, we have vector u plus vector v. The magnitude of the addition of these two vectors. Either it can be the addition or else it can be the subtraction. So the square root of this is equals to square root of this magnitude u plus square root of this magnitude vector v plus or minus 2 times square root of vector u into, 2 times the multiplication of these two magnitudes, these two vectors magnitudes. So here we just applied the same thing. It's like a plus b squared is what? A plus b squared means a squared plus b squared plus 2 times ab. So then if we have a minus b squared, a minus b squared is a squared plus again b squared minus 2 times ab. So the same thing, this a has been replaced by the vector u, this b has been replaced by the vector v. Is it clear?
Yes.
Okay. Now that's up to this point. We are done with that part. Okay. Now, so to find out distance between 2 points, so what we have here is, we have the origin here. So let's assume we have 2 points. Here we have point P, here we have point Q. Now, so this one is OP vector, this one is OQ vector. If we wanted to find out this magnitude of this PQ, okay, how we gonna find out that one? Magnitude of this PQ means actually what? So PQ vector means what? PO plus OQ. PO plus OQ. So PO, okay?
Yeah.
So PO plus OQ. So if we define this vector P, as x1, x2 to xn, and if we define this vector Q as, if I define this one as y1, y2 to yn, now what will happen? We can have this PO plus OQ as y1 minus x1 squared plus y2 minus x2 squared plus yn minus xn squared के complete square root. Is it clear? So
Yes.
PO plus OQ, no? Then the vector
Yeah.
P, we have to compare it with the origin. So we have this OP and OQ value. Then that is basically P minus Q1. Sorry, Q minus P1. Okay. Can you do
Yeah.
this example? Try it out this example 3. This example 3. Try it out the example 3. Okay, done. Were you able to figure out?
Yeah.
Okay, so it's easy, right? You can have the
Yeah.
subtraction and okay, that one is good. Now, now we have a special vector called unit vector. We have a special vector called unit vector. How we define this unit vector, that is very easy. Let's assume we have a vector called u. If we find out the magnitude of that vector u, then if that magnitude is equals to 1, we call that vector as a unit vector. The condition would be magnitude of that given vector should equals to 1. Okay, that's what here they have defined. A vector whose magnitude is 1 called unit vector. Or the vector u, we can define it as the magnitude of this vector u is equals to 1. Then if and only if that u, vector u, is a unit vector. Okay? Okay, is it clear?
Yes.
Okay. Now, so how we define these vectors? So anyway, if we have kind of 0, minus 1, 0, 0, if you find out this 4-dimensional vector and if you find out the magnitude, this magnitude would be 1. So these kind of vectors, we call them as unit vectors. Anyway, unit vector means on that vector, the magnitude of that vector is equals to, on that magnitude of that vector is equals to 1. That's what there we have. Okay. The process of multiplying a vector u by a reciprocal of its magnitude to get a unit vector. To find out the unit vector, this one is important. To find out the unit vector, how we gonna find out this unit vector? That is, the given vector u should divided by the magnitude of that vector. That's how we can find out the unit vector in that direction u. Is it clear? So let's assume we have that vector u like this. Okay, we need
Yeah.
to find out the unit vector. In Sinhala, we call them as the Ekakadaishika, unit vector. To find out this unit vector, since we have this vector u, we can divide this vector u by the magnitude of this u, which then we can have the unit vector. Okay? So, for the unit vector, for that same direction, vector u. Okay, we are finding unit vector for the same direction, vector u. Okay, let's assume we have another vector called v. Okay, for the vector v, let's assume this vector v is equals to vector u divided by magnitude of this vector u. That means this one is the unit vector for the same direction, vector u. But what will happen? If we have this vector v called minus vector u divided by magnitude of this u? If we have minus here, so I am referring to these points. If we have minus here, now what will
Yeah.
happen? That means the opposite direction as vector u. So same thing, still it's a unit vector because the magnitude we brought it as 1. Then magnitude is equals to 1, but the direction has been opposite. So we have the opposite direction. Okay? Okay?
Yeah.
Okay.
So
Now
what
that,
is so what is the
sorry?
U?
Hmm.
So the what is the U line vector over magnitude?
What? I didn't get you.
So you know it's unit vector because how to find unit vector? If
Yes, how to find the unit vector. Okay, if I do kind of an example, let's assume, let me show you. So the vector u, if this vector u, they have given 2i plus 3j. Okay, let's assume they have given like this. Then, so what we have to do to find out the unit vector for the direction of vector u. So what we have to do? Vector u should divided by magnitude of this vector. So that means vector u is 2i plus 3j and it should divided by, now what is the magnitude? Magnitude is 2 squared plus 3 squared. 2 squared plus 3 squared means 2 squared is 4, 3 squared is 9. Altogether we have square root of 13. That means 2i plus 3j should divided by square root of 13. That means 2 over square root 13i plus 3 over square root 13 j is the unit vector. If you find out the magnitude of this one, then it will equals to 1. That's how the example works. Okay?
yeah.
That part is done. Then, yeah, standard or the basic vector. Do this example 5. Example 5. Vector u is given as minus 3i plus j minus k. And the vector v, they have given minus 2j plus 4k. Then they ask us to find the unit vector in the same direction, vector u plus vector v. Then first what you have to do? You have to find out the vector u plus vector v. Try to do the example 5.
So 2 line in magnitude.
Magnitude or the vector? 19, 19. 19 is the magnitude of this vector u plus vector v. Then what about the vector u plus vector v? Okay, done?
Yeah.
Did you get the given solution? That is minus 3i minus j plus 3k should divided by the square root of 19. Square root of 19 means the magnitude of this vector u plus vector v to get the unit. It's clear, right? Were you able to figure out, or do I need to do this one?
Why do you square it?
Square root.
Yeah.
So to find out the magnitude, how are we going to find out the magnitude? So vector u, they have given as minus 3i plus j minus k. Vector v, they have given minus 2j plus 4k. Sorry, minus 2j plus 4k. Yes, there's no any I components there. Then what will happen? First, we need to find out vector u plus vector v. Vector u plus vector v means what's the answer? So there's no any I component here. Then minus 3i, okay, minus 3i, then minus j plus 3k. Did you get this one as the vector u plus vector v?
Yeah.
We just add these two vectors. And what we have to do, we have to find out the magnitude of this one. To find out the magnitude of this one, we need to square all these components. So which means we need to square all these components and add all these components together and find out the square root. You know, minus 3 squared plus minus 1 squared plus 3 squared, which means minus 3 squared means 9, minus 1 squared means 1, again 3 squared means 9, then the square root of this one, that is equals to 9 plus 9, 18, 18 plus 1, that is 90. Okay? So to find out this unit vector, to find out this unit vector, what we have to do, we need to divide this vector, because we are finding this unit vector to the direction of this vector u plus vector v. So we are finding the unit vector, which means the magnitude should be 1 for that same direction. So then this vector should be divided by the magnitude of that one. That is minus 3i minus j plus 3k divided by square root of 90. Is it clear? Are you sure whether it's clear?
Yes.
Okay. Example 6 also. Just do this example 6 and take some water and come. Example 6 as well as the example 7. Okay.
Yeah.
So what about the example 6? Can manage? So how we
Um,
gonna? Okay. So how are we gonna find out this one? They have given that vector u and vector v are perpendicular unit vectors. Perpendicular means it's cross. What would be the degree?
90.
90. Yes. Then they have asked us to find out the magnitude of this vector. Okay. So what we have to do, so let's assume we have this vector u like this. So the given vector u is like this. And what about the other vector? So you need to sketch these ones. This one would be vector v. So this vector u and vector v are perpendicular unit vectors, which means the magnitude of these ones are equals to 1, right? If we
Yeah.
take the magnitude of this vector u, that is equals to 1. If we take the magnitude of this vector v, that's also equals to 1. Now what will happen? If these two are perpendicular unit vectors, what happened with this u dot v? What happened with u dot v?
Oh.
So if these two are perpendicular vectors, then the dot product will be 0. The dot product will be 0. Can you remember when it comes to dot products? Let me show you. Where we, okay. So here, where we did this vector dot product. Okay. See, we already discussed if those two vectors are orthogonal or perpendicular. If this u and v vectors are orthogonal as well as, or else if those two vectors are perpendicular, we prove that the dot product of these two vectors equals to 0. Can you remember that one? So, okay. So here also what will happen if these two unit vectors are perpendicular, which means the dot product is equals to 0. But for these two separate vectors, the what we call the magnitude of these two vectors separately is equals to 1. Is it clear how we think up to this point? Are you sure?
Yeah.
And then we need to find out what? The given vector, resultant vector. It's like a resultant vector. 1 over 3 u minus 2v. So how are we going to do that? This one is actually how we going to do that? So this is equals to what? 1 over 3 vector u minus 2v dot 1 over 3 u minus 2v, which means here we have square root of the same thing, square root of 1 over 9, okay, 1 over 9, what? 1 over 9 this one plus 4 times this one. Now what will happen for this one? We can say that actually this one is vector u dot vector u. Here we have vector v dot vector v. So which means 1 over 9 u dot u plus 4 times v dot v. So u dot u and v dot v we considered as 1, right? So u dot u is equals to 1 as well as v dot v is also equals to 1. Then here we have 1 over 9 plus 4 complete square root. Okay, that's how we get the square root of 37 over 9. Is it clear what I did? If you have any questions, just ask from me. That's totally fine.
How did you turn the 1/3 u minus 2v into
Yes,
two
into
brackets?
these two, okay, into these two vectors. Let me show you. So earlier, when we did the scalar or the dot product, can you remember that we did? Let me show you the theory so that you can. Okay, so here we are talking about the magnitude for the first time here, no? Okay, which means how we define that one as here. Okay, if I show you, okay, so let's do like this. So if it's not clear why we use this dot product, okay, why we use this dot product, okay, let me show you. Now, here what we have to do, magnitude of, we need to find out magnitude of 1 over 3 u minus 2 over vector v. That one is normally, if we go through with the theories, how we define this one, okay? 1 over 3 u's complete squared plus 2 over v's complete squared. Is it clear? This one is clear. No? We just square these components and add those two together and take the square root. Now what happened? Now what happened? 1 over 3 squared means 1 over 9. No? 1 over 9 vector u squared plus, okay, 1 over 9 vector u squared plus 4 times vector v squared. Okay. From that dot product, can you remember vector u dot vector u, what was the answer?
1.
1. Vector v dot vector v, what was the answer?
1.
1. There, for the dot product, let's assume we have two vectors like this u and v. And also these two are, maybe these two are moving on a single point or the origin, or else these two are coming towards this, for this origin. So the angle in between these two is theta. Then we define this dot product as u dot v, okay, u dot v is equals to magnitude of u, okay,
Yeah.
plus magnitude of this v, sorry, plus in the sense, I just wanted to say you vector u dot vector v is equals to modulus magnitude of this vector u into magnitude of this vector v into cos theta. That's how we define this dot product. Again, let me show you that one, so it's easy for you to understand. Dot product. See, if I show you this one, it's easy for you to understand. So if we consider this dot product with angles, okay, dot product with angle. See, how to find this dot product is A dot B is equals to modulus A into modulus B into cos theta. Now here A and B are vectors. Theta means actually what? Theta means the angle in between these two vectors. So if I show you with an image, okay. So if I show you with an image, give me 1 minute. So it's easy for me. Okay. See, now take this. See, this is how it works. So we have two vectors called A and B, and those two are intersecting each other with the angle theta. Then we define this dot product or the scalar product A dot B as how? Modulus A into modulus B into cos theta. Is it clear now?
Yeah.
That's why we are getting, that's why here they are getting this u squared and v squared 1. Now
Yeah.
we can rewrite it as 1 over 9 plus 4, that is 37 over 9. The square root of this 37 over 9. Is it clear now?
Yeah.
Okay. We'll do a few more questions, then that will be fine. Okay. If I move forward, so yes, we did up to this. Now read the example 2. So example 2, they have asked us to do, show that the vectors u is equals to 7, minus 2, 4 and vector v is equals to 2, 5, minus 1 are orthogonal. Now to find out, we need to show that these two are orthogonal. So what would be the condition then? We need to check if the dot product is equals to, okay, this one is not that one. Okay, we were doing here. Okay, 37 over 9. So for the example 7, can you try this example 7?
I have a question. You know, in the example 4,
Example 4. This one is example 4.
how do you know it's magnitude 1?
How do we?
How do you know it's magnitude 1?
So how we how we find out the magnitude? Normally.
Oh, yeah.
For the example 4. So let's assume we have the vector u as so here 0x minus y. Okay, we'll use the what we call ij. So they have defined this u as 0, minus 1, 0, 0. Okay. So if we take the magnitude of this vector u, how we normally take the magnitude of this vector u? We just square what? We just squared all these components now. So for example, if they have defined this, vector u as minus 3 comma a comma 2 comma minus 4, how we find out this magnitude u? That is minus 3 squared plus a squared plus 2 squared plus minus 4 squared. Is it clear? This part, this one, how we find out this magnitude u, Kiyanaka?
Oh, yeah.
Okay, if so, then if we find out this magnitude u, that means we need to take the square root of addition of these components squared. That means 0 squared plus minus 1 squared plus again this third dimension, again it is 0, 0 squared plus here again we have 0 squared. So all together for the square root of this one, 0 squared plus minus 1 squared plus 0 squared plus 0 squared means we have the answer as 1. So the square root of 1 means 1. So the magnitude of the vector u is equals to 1. You can take the square root of addition of these squares. Is it clear?
Yes.
Now, if we have, so for the fourth example, let's see, we have 1 comma 0. 1 comma 0 means it's two-dimensional one because we have only two components there. Let's assume vector u is equals to 1 comma 0. Now what will happen? Again, to find out this modulus u, which means the magnitude of this u, that is 1 squared plus 0 squared, then the square root. Again, that is equals to 1. That's how we normally take the magnitude of a vector. Okay. Then for this new one, what we have to do? Now they are telling example 7, let the vector u be minus 5y plus square root 3j minus 2k. Then find the unit vector in the same direction u and find the unit vector in the same opposite direction. That one also easy. How we get the unit vectors for those ones?
Wait, for example 4,
Hmm.
how is 1/4, 1/4, 1/4?
Okay. See, that one also easy. Now, the vector u they have defined as 1/4. 1/4. 1/4. 1/4. How to get the modulus u? So that is 1/4 squared plus 1/4 squared plus 1/4 squared again plus 1/4 squared. Then what we need to do? So we need to add all these values together and get the square root. That means this one is not a unit vector, right? The magnitude is not equals to 1. Yes. So here we have 1/16 into 4. No? So 1/16 into 4 in the sense we have 1/4. Square root of 1/4. Square root of 1/4 means that is half. It's not equals to 1. It's not a unit vector. Yes. To show that, that's how you should show. You need to calculate calculate means you need to find out the magnitude of this vector u and then say it's not equals to 1, because of that it's not a unit vector. Okay, now it's clear, right?
Yes.
Okay. Do the examples. Okay, example 7 I'll let you to do as a homework, otherwise it will take some time. We need to complete these vectors and move to the next lesson. See here we have that now only they are defining this one. Angle between two vectors. Now I already told you this one. Okay. Angle between two vectors. If u and v are non-zero vectors, so both this vector u and vector v should not be 0. So u and v vectors are non-zero vectors in R squared or R cubed, which means it might be two-dimensional space or else three-dimensional space. And if theta means theta is the angle between them. So for example, if I draw a sketch, here we have vector u and here we have vector v. Okay, so the angle in between these two vectors are u. Then to find out the angle, the value of this angle, how we gonna do that? We need to calculate the dot product of these two. So the vector u dot vector v is equals to, we define it as modulus of vector u into modulus of vector v into cos theta. Okay, then to find out this angle cos theta, cos theta is equals to actually vector u dot vector v should divided by modulus u dot modulus v. This is what we have. Is it clear?
Yeah.
Now we have the expression for cos theta. To find out the theta angle, then what we need to take? We need to take the inverse of both sides. Then to find out this theta angle, theta is equals to cos inverse u dot v divided by this one, modulus u into modulus v. For this one, theta should be in between 0 to 5 angle. Is it clear? How to find the angle between two vectors? Now
How
what
do we
will
get
happen?
pi?
Huh?
How do we get 0 and pi?
0 and pi. If it's 0,
Yeah.
no? If it's 0, no, what will happen? If it's 0 means it's with the same direction. There's no any angle here. Then cos 0 is equals to 1. So you are saying if the theta, you are asking what happen if the theta is equals to 0, right?
Yeah.
If the theta is equals to 0 means how this sketch looks like. There's no any angle. The value of this angle is 0, which means if we have this u, then v also in same direction. There's no any angle in between these two. So that if the theta becomes 0, theta becomes 0 means cos theta is equals to cos 0 is equals to what? Cos 0 is equals to 1. So then this part will equals to 1, which means if the theta angle is equals to 0, then the u dot v is equals to modulus u into modulus v. Okay? Is it clear?
Yeah.
Okay. Then what we have? Then what we have? So if we move for the next definition, two non-zero vectors u and v are said to be orthogonal or perpendicular. Tell me that. Tell me this. So if these two vectors are orthogonal or perpendicular, what will happen then? If these two vectors are orthogonal or perpendicular, which means if we draw this one, here we have the vector u, here we have the vector v. Now the angle is in 90 degrees now, which means u dot v is equals to, I'm using the same equation. Now we know for an general theta angle, the equation will be u dot v is equals to modulus u into modulus v into cos theta. Now this cos theta, theta angle is 90 degrees. Okay. Now what happened with the 90 degrees? Cos 90 means cos 90 equals to what?
0.
Cos 90 is equals to 0. If we multiply this 0 from these two magnitudes, then again this will equals to 0. That means if these two vectors are, if two vectors are perpendicular, then their dot product is equals to what?
0.
That's how we showed it with this method. Is it clear now? No?
Yeah.
Okay. So then that's what they are saying here. Two non-zero vectors u and v are said to be orthogonal or perpendicular if and only if these two are the dot product is equals to 0 and the theta angle should equals to 90 degrees. That's what here they have mentioned. Okay. Can you try this example 1? Just try this example 1. I think we have covered all the theories. Yeah, example 1. Are you trying?
Yeah.
Okay. What they are saying here. Let magnitude u is equals to 3 and let magnitude v, I mean the magnitude of the vector v is equals to square root 2. Then they have given this, that one is easy, u dot v is equals to 5. So what we have to do, always keep like a habit to draw the sketch and do. So here we have vector u, here we have vector v, and marked all the given details there. Vector u, magnitude of this vector u is equals to 3, and magnitude of this vector v is equals to square root 2, and mark this theta angle, whatever we are going to find out. Then you can apply the rule u dot v is equals to magnitude of u into magnitude of v into cos theta. Okay.
Yeah.
So u dot v means U dot V means there we have U dot me means they have given as 5. 5 is equals to modulus of vector U, that is 3, into modulus of vector V, that is square root 2 into cos theta. Then this cos theta is equals to 5 over 3 square root 2. Then theta is equals to actually cos inverse 5 over 3 square root 2. Okay, that's what here we have. Okay, now you can write out this example 2 as homework, example 3 also as homework. Then we'll move to the next theorems. Okay, for these theorems, if we add or subtract these two vectors and get the square root of the magnitude, then what will happen? We did this one earlier. Square root of, not the square root, magnitude, square root of the magnitude of vector V plus square root of the magnitude of vector V plus or minus what? So I think we did that one earlier, where we did that one. See, plus or minus 2 times vector U, vector V. So here also we have the same thing. Same thing, but in different way. So 2 times vector U, vector V means actually vector U into vector V into cos theta. Okay, so these ones are new theorems. First one, this is first theorem, and the second theorem will be the squared of this vector U plus or minus vector V. The squared means actually the magnitude square, magnitude square of that one is equals to this vector U squared. Okay, I'll show you how we define this one. I think for your age, that one is not no need. The proof of these ones, anyway, I'll show you how to prove. But for now, you just remember, or you just go through with these theories. Just recall these ones, so we can rewrite like this. So what will happen? Vector U plus or minus vector V for the squared. How we define this one? Vector U squared plus vector V squared plus or minus vector U vector V cos theta. And then the second one will be vector U plus or minus vector V is equals to first one's squared first one's squared plus second vector's squared if and only if when what? This entire part is equals to 0. This entire part is equals to 0 means cos theta. These two are non-negative vectors, no? These two are non-zero vectors, no? Which means this cos theta should equals to 0. Cos theta is equals to 0 when this theta is 90 degrees. When the
Oh,
theta is in 90 degrees. Is it clear?
yeah.
Okay. And then the third one, again we have vector u plus vector v. The modulus of this one is equals to modulus of this one is again what? How it becomes these two are equals. So if we consider this one, then we can rewrite that part as u squared plus v squared, okay, u squared plus v squared plus u v cos theta.
This for the hot age here.
Okay, so for the negative one, how we define that one? Again, u squared plus v squared. If it's negative, then this one should be negative, right? Now again what will happen? So as they said, these two are equal, which means this entire expression should equals to this entire expression. That means this entire part should equals to 0, right?
Right. How did
Uh,
u plus v squared turn to just u plus v? And where did u v cos theta?
this one?
Yeah.
The second one?
Yeah. Yes.
Okay. Okay, let me show you. Actually, there they have made kind of few corrections. Let me show you the proofs and stuff as well. The correct expressions would be how we define this one. Modulus, first one, u plus so minus vector v, okay, is equals to this one's squared is equals to modulus u squared plus modulus v squared plus or minus 2 u v cos theta. Let me show you first how we define this one. We'll get u plus v. Okay, so we are going to find out u plus v. So if I draw a sketch, here we have u, here we have vector v. Now the angle in between these two, angle in between these two vectors, it's equals to theta. Now, how we prove this one? That is, we need to draw a parallelogram. First, we need to draw the entire parallelogram. Then, so this one is vector u, no? Then this one is also again vector v. Now, vector u plus vector v means, if we wanted to calculate this vector u plus vector v means, actually what? This entire diagonal. Is it clear? This entire diagonal will represent, okay, this entire diagonal will represent what?
U square plus V square.
No, let me show you.
Yes.
Let me show you. So how we define this one? This is actually u plus v. Give me 1 minute. I'll just show you how to get that one. I'm just trying to find out few things so that it can easy for you to. Okay. Here we have that one. I just wanted to have this entire proof. Give me 1 minute so that I can. Okay. Okay, let me show you. So that it will clear for you too. Okay. Now we have this one. So here we have vector u plus vector v. This is the summary. Summary in the sense resultant force. Okay. Now here we have this vector u, and here we have this vector v. So we can, if we complete this parallelogram, this entire u will become here as well. This v we can replace here as well. From this diagonal, we can calculate the vector u plus vector v. Is it clear? Up to this point? Okay. Now what will happen? I just make a I just make a right angle triangle here. Okay, I just mark a right angle triangle here. Now what will happen? So here we have the 90 degrees. Okay, here we have the 90 degrees. And now we have two lengths here. Now what will happen for these two? So if this angle is theta, what about this angle?
Yeah.
That's also what?
Theta.
Theta, no? This one also
Yeah.
theta. So if this one is, okay, if this length is, length in the sense, so this vector, what it's represent is vector v, no? Vector v means the length of this side, it will become magnitude of this vector, right? Now that means we can consider this one as what? V cos theta. And for this one as that is V sin theta. Is it clear?
Yeah.
We just divide this one into this one. I just used this one. Okay. Then what we have to do now, so you can consider this entire right angle triangle and apply the what? And apply the Pythagoras theorem to that one. So how it works? Okay. U plus V's, okay, magnitude of this length squared is equals to, I'm just applying the Pythagoras theorem. Then this one will be U plus V cos theta. Okay, U plus V cos theta squared plus here we have V sin theta squared. Is it clear? Now, I just applied the Pythagoras theorem to this entire right angle square. So, for the left hand side, we have this one. Now, I'm going to solve this one for, now I'm going to simplify the right side. If I simplify the right side, here we have magnitude of u squared plus 2 times magnitude of u into magnitude of v into cos theta plus magnitude of v squared cos squared theta plus here we have magnitude of v sin theta squared. Is it clear what I did? I just simplified it. So first one squared. Here we have a complete squared. No? Complete squared means here we have a squared plus b squared type of thing. We can replace this one. We can simplify this one. Remove the brackets. U magnitude of u squared plus 2uv cos theta plus v cos theta's complete square. Is it clear? Then
Yeah.
here we have v sin theta's complete square. Now, if I consider these two, we can take this v squared out. Then here the remaining part will be cos squared theta plus sin squared theta. No? Cos squared theta plus sin squared theta means 1. So which means this entire part will be more simplified for what? V square. That's how we receive modulus of u plus v squared as u squared plus v squared plus 2u v cos theta. Is it clear now? This is the entire proof how we get this equation. What happened? Is it too much?
No.
Are you sure it's clear? Anyway, you can go through with the entire video again. No? Then that's fine. I'll upload the entire recording so that you can refer it. No? Do you want any explanations or shall I move forward? You want me to explain this one time? Again?
Oh, yeah.
Okay. So I'll do it again in a clear way. Okay. Now we need to find out u plus v's squared. So just assume that vector u is in this side. Now vector v is in this side. The theta angle is in between these two. Okay, now we are going to find out an expression for this. So here we have u plus v, vector u plus vector v. If I complete this one into a parallelogram, for this side we have vector u. Sorry, vector v. Okay? Vector v. For this side we have vector u. Now what will happen? The resultant force or the resultant vector will be, so u plus v, now we need u plus v means this. If I starting from here, u plus v. So here we have the u plus v vector. Is it clear, that part up to this point?
Yeah.
Now I'll be drag this side until I can complete a right angle triangle. So here I'm completing a right angle triangle. So what about this length? This length is the magnitude of vector v. Is it clear? Okay, this length is magnitude of vector v now. So this entire length, so if it's represent the vector v, the length of this side is the magnitude of this vector v. Now, if this angle is theta, what happened with this one? This also theta. Is it clear?
Yeah.
Now, since we have this length as vector v, okay, since we have this length as vector v, this length will be what? Magnitude of vector v cos theta.
Yeah.
So this one will be v sine theta. From the vectors now, here we have the vector v, then we have vector v cos theta this side. Okay, I'll show you it from the vectors. It's easy. Otherwise you will how to erase this part. Okay. So okay, now this length was representing vector v, so which means here we have v cos theta vector. Here we have v sine theta vector. Is it clear? V cos theta and V sin theta. I just divide this entire one into these two, sine and cos, for the adjacent as well as the opposite side. Now what I'm going to do is, I'll just apply the Pythagoras theorem to this entire right angle triangle. There, then we received, now see, u plus v's magnitude squared, because the Pythagoras theorem, it says a squared plus b squared is equals to c squared. Okay, c is the height. So height squared means the length. We have to convert it into length now. Length in the sense, so length we can get the magnitude of this vector u plus vector v, that one square. This one is equals to this one squared plus this one squared. Now u plus v cos theta, we need to take the magnitude, that one squared plus v sin theta squared. Is it clear up to this point?
Yeah.
Now what you have to do, you just need to simplify the right hand side. So what will happen? If I simplify this one, then we have u squared plus 2 u v cos theta, okay, 2 u v cos theta plus v cos theta's complete square. Is it clear? Plus v sin theta's complete square. Which means now here we have u squared plus here 2 u v cos theta. Now what happened with these two? Here we have v cos theta squared plus v sin theta squared. So here magnitude of v and magnitude of v means there we have a length, no, magnitude. So we can take this out and then the remaining part is cos squared theta plus sine squared theta. So cos squared theta plus sine squared theta is equals to what? 1. Then that means this entire thing will be narrowed down to equals to v squared, magnitude of v squared. Is it clear?
Yeah.
Now the final statement will be u squared plus this v squared plus 2 u v cos theta. These entire things are magnitudes, the length of these parallelograms. Is it clear? These vectors. So which means this u plus v's magnitude squared is equals to u squared plus v squared plus 2uv cos theta. So we can simply say that, okay, if we have this vector for this side p, if we have this vector vector q for this side q, and then if we have this angle in between these two vectors as theta, then if I draw the resultant force like this, that one we normally represent this r, no? Then we say r squared is equals to p squared plus q squared plus 2pq cos theta. That's how it works. Is it clear now? Up to somewhat?
Yes. Yeah.
Yeah. So that is it. Okay. Then, so here also they have made a mistake. So there they should have 2 here. Okay. Now what will happen? To equal these two sides, okay, if this entire expression is equals to only this entire u plus v's magnitude of this one squared should equals to this one kilo means, then this entire 2uv cos theta should equals to 0, no?
Yeah.
See, this entire part should equals to 0. But we know that u and v are non-zero vectors. So there should be a magnitude for these ones. Then only thing can be happen is cos theta should equals to 0. So cos theta is equals to 0 when theta is equals to 90 degrees. Because cos 90 is equals to 0. That's where this entire expression 2uv cos theta becomes 0, which means if these two u and v vectors are in perpendicular, then u plus v is equals to u squared plus v squared. That's what they have mentioned there. See, if these two are perpendicular vectors, then the angle is 90 degrees. So cos theta becomes 0, which means we can simplify this u plus or minus v squared into is equals to u squared plus v squared. Okay? Is it clear?
Yes.
Okay. Then the same thing happens here. To become these two equals, are you sure? Do I want you to show it again? Show the working.
No.
Okay. Okay. So actually what will happen? Okay. So this this entire one should equals to 0, but magnitude of u and v are not equals to 0 because those two are non-zero vectors. So there should be a value. Then cos theta, the only thing that can become 0 is cos theta. Cos theta is become 0 when theta is equals to 0. The same thing happens for the third one as well. There we have the same thing. So that the middle part to become, okay, I'll give you kind of a homework. Now, I have already proved this one. I have already proved this entire expression with this one. As a homework, try to prove these two. Okay. So now, for the first theorem, we have already proved this entire. So, do the proof by using the first one. Okay, by using the first one for the B and C as well. It's a homework. Okay. And then do the example 4 as well. Do the example 4 as well as the homework. So today we already did all these vectors. No, I'm not moving to the cross product. So we'll do cross product tomorrow. We have already completed the dot product. Then we have to move for the cross product. Sorry. Okay. So you just do all these two again. So by looking at this first one, you can do the proof for the B and C as well. And then you just do the example 4. Okay, and there are kind of remaining examples as well. Now you need to try it out. Okay, is it
Which
clear? Okay, okay, then we'll do
which
the. Uh,
which examples?
so I just marked here the example 3 you need to do, example 2 you need to do, and so see example 7 also you need to do. I'll send you this this tute again, so that I have already marked all these example all these homeworks here. Okay, and also I'll upload the recording as well, so that you can clearly have the you can look again for this entire what we have the dot product ones, then we can move to the cross product tomorrow. Okay, is it okay? Okay.
Yes.
Okay. Okay, then see you tomorrow with the PO one as well. So I'll send you those ones now, so that you can work these ones. Then we'll do the cross product next day. Thank you so much for joining. See you. Have a great day.
You too. Bye.
Bye.